Hi, my name is Joachim, and welcome to this presentation of a software architecture called Polylith. Can you guess what this is? And yes, this is actually a service. And this is typically how we organize code today, by putting all code needed into one place. And we also do one more thing. We also organize the code in some nice way, maybe into domains. And if it's a service, we need to expose it so that it can be used. And we also put some effort to give nice names to those domains. But what is a domain? In an object-oriented language, this would live in a namespace, and each box would be an object. And if we zoom in, each object would have a set of methods. And this is a very common way of building software today by using an object-oriented approach. But what happens if we get performance problems, let's say in the payment domain, and that we think that scaling out would be the right solution? Then we need to add a new service. And now we also need to write some code to be able to expose this service. And now we can delegate to this new service and move the payment related code into that domain. But now we realize that we had some code written to be able to communicate with the database. But let's copy that code. Oh, some more code. Okay, let's copy that code too. And what have we done here? We have written some code to be able to expose this service. And that's great. But we also had to delete code and copying code. And that's not so great, because that can be both time-consuming and boring. And here, we did something else. We duplicated code, and here we duplicated some more code. And that can be a maintenance problem, because now we need to maintain the same code in two places. And if we find a bug here, we need to remember to update it here too. And that's not an optimal situation. But maybe we can do better than this. And what if I told you that I have a solution for this? And this is what I'm going to talk about today. What is Polylith? How does it work? And why you should use it. Let's start with what is Polylith. Polylith is a modular software architecture where you can create systems by combining system-level building blocks. And it's mostly for the backend. It's free and open source, and it's mostly a way of organizing the code. And therefore, it's also language agnostic. And you can basically implement this in almost any language of your choice. But how does it work? If we go back to our service, in Polylith, each domain would be a component. And what is a component? In a functional language, we would expose a set of functions that would live in the interface namespace, or payment interface in this case. And Polylith is a functional way of organizing code. And you may think, what is a functional way of organizing code? What is functional programming about? Is it about recursion or whatever? But no, if you ask me, I would say that a functional style is about thinking about solving problems by processing things in small steps. It's more about focusing on what to do instead of thinking about figuring out what things are. So instead of thinking about should this be a car or something else, you can focus on processing things. You send something in and out comes something. And so in Unix, for example, you can pipe things with those pipe characters and perform things in steps like in a pipe. And you can think about a component as a set of pipes where each function is a pipe. And they are connected, or actually when you put components together, you kind of extend those pipes. So it's very focused on processing things. And that's really cool. So let's go back to our component here. Each function here just delegates to other namespaces within this component. And often it's just a one-liner. And if we want to implement this in an object-oriented language, it would look very similar. We would have a set of functions. So we need to remember to declare each function or each method static to turn them into a function. And those functions would live in the payment class. And because a component is static, or stateless, we don't instantiate those classes. And everything would live in the payment namespace in this case. And how would it look like if we want to use this component from some other part of our system? Then we just import this class, and now we have access to all those functions. And it's just code talking with code directly with function calls. No magic, no dependency injection or something like that. And we also get IntelliSense. And that's a really cool. I mean, especially if you implement this in a functional language, that's a really great way of organizing your functions. And it is as great in, anyway. So it's a really nice way. That was what I was going to say, to organize the code, because it feels almost like you are working in a object-oriented language if you take the good parts, if you implement this in a functional language. So what are the benefits of using components? A component is small, and that's good. It's smaller, or it's bigger than a class, but smaller than a microservice. And in the project I worked in, the average size of a component was 400 lines of code. So they can be very, very focused on one task. And they are also easy to reason about, not just because they are small, but you can also give them a nice name, and they only expose a set of functions in its interface. So, and that interface is easy to find also, because it's always the same name of that interface or that namespace. And they are like Lego bricks. You can think of a component as a code snippet that you can use everywhere, so you get reuse, and you can combine them in any way you want, so they are composable. And you can also replace a component easily if you have another component with the same set of functions in its interface. So they are replaceable also. And altogether they are very much like building with Lego bricks. And we have something more here also, something we call a base. And what is a base? A base is very similar to a component. It has a descriptive name, and but it doesn't have an interface. Instead, it exposes a public API. And that could be something like a REST API, a Lambda function, or a main function, if it's a standalone application. And what it does is that when it receives the call, it just delegates to other components. And you never put domain logic into a base. It's just delegation to other components. So a base is just a thin layer delegating the incoming call. So let's go back to the service here. How would it look like if we want to perform those refactoring steps using components? Then, the first thing we do is that we create a new service. And now we can just move this payment component into that new service and the other components it uses. And this is something that takes seconds to do. You don't need to delete any code, copying any code. It's just a configuration thing. And now we can just replace the old payment component with the payment remote component in this case. And this component has the same set of functions in its interface, so the surrounding code doesn't notice any difference here. And what it does is that it just delegates to this new service. And what have we done here? We have written the minimum amount of code to be able to delegate to this new service or use this new service. But we haven't introduced any code duplication here, because in Polylith, the same component can be used in more than one place. Let's see how this would look like. If we go to our development environment and open up a component and start to edit it, then all the changes would immediately be reflected in the services that use this component. And this is cool. And this is actually what Polylith is about. To give you a really effective development experience where you can work with all our code from one place, so that we can navigate the code, refactor the code, and debug the code. And this gives us a really fast feedback loop. And the other thing Polylith helps us with is that it gives us a really flexible deployment experience. And in Polylith, we can postpone decisions on how to execute the code in production. And we only introduce new services when we need them. And it could look something like this. In our production environment, we can optimize the code for non-functional requirements like performance, while at the same time, in our development environment, we can optimize for productivity and keep it simple. And this is really core to Polylith and really important and powerful also, that we can keep those two things separated. And if you ask me, this is how you should build software. I mentioned that a component could be used in more than one place. And this can be solved in mainly two ways. One is by using symbolic links. And here we have three top directories: components with all our components, bases, and services. And if you're not familiar with symbolic links, they are just placeholders for a file or a directory. And here, for each service, we just add a symbolic link for each component and the base to create a new service. So we are faking that the code actually lives under each service, but it's just an illusion. And it's a way of introducing reuse. The other way of solving this problem is by using a configuration file. And here, in our build file, we add a section where we list all the source folders for our components and the base, and now we have a service. And when we want to add another service, we just add another section in the same build file where we list all the components and the base, and now we have another service. And you may notice here that we didn't have to delete any code, copy any code, or duplicate any code here. It's just a simple configuration. And at the same time, we could keep the development environment intact. And as I said, this is a really powerful and simple idea, but very useful. And as I said also, I think this is the way you should create software. And we should ask ourselves, does it work? And yes, it works. And I can say that because I've been using this for 3 years in production, full time. And not just me, but other companies too. And here we have a number of systems of different size. Some uses REST and some uses Lambda functions, but they are just example systems. And what Polylith helps you with is that it makes the systems easier to reason about, easier to change, and easier to test. And it also increases the quality of your systems. And as a developer, it makes me more productive also. And if you add all those things together, then it's just good stuff. And if you want to answer the question, does it work? We could actually, yes, it works. To summarize, keep it simple. Use small Lego-like building blocks that you can combine. Work fast from a single development environment. And have fun, because building with Lego is super fun and I can really recommend it. But who made this? I came up with the idea, but we have been a whole team working on this together, me, Furkan and James. And by the way, they are really awesome guys. And if you're curious, check it out. We have a lot of documentation, high-level documentation, videos, example applications, and so on. And that was all for me. And let's hope your next project will be a Polylith project. And happy coding!